These are the solutions to the proportional reasoning review. As you go through these, if there's anything you didn't have, please add it. If there's anything that you had done incorrectly, please change it so that your review sheet is correct. All right, number one, list 3 characteristics of a proportional relationship. So the 3 things that you should have, the graph forms a straight line and passes through the origin, and you can also write the equation as y equals kx, where k is the slope, it's the unit rate, and then it's also the value that makes that equation work. Number 2, define the constant of proportionality. What are the 3 ways the constant of proportionality is represented, with an example for each? So the constant of proportionality as a definition really is just unit rate. It's how much for one of something else. So we can write it as a unit rate. An example would be 3 miles per 1 hour. It's also the slope if you're looking at the graph, so that would have a slope of 3. And if you have the equation, it's the value for k, where y equals kx. So for this example, it would be y equals 3x. All right, next, a car travels at a constant speed of 60 miles per hour. List 5 coordinate points that lie on the graph, including the unit rate. So we know this is a proportional relationship, so we're going to have 0, 0 as one of them. You do need to have them in the correct order. If you switch them, then your graph has different axes. Since we need time along the x-axis, so how many hours on the x-axis, you're going to have 1, 2, 3, and 4 as possible x values. This one right here is your unit rate, and I want you to label that because it did ask you to include that one. And I know it's the unit rate because that represents 60 miles per hour. That's the ordered pair for that information. All right, number 4, an hourly employee earns $8.50 per hour. How many hours will he need to work to save $127.50? Solve it 3 different ways. So you're not just filling in the 3 different ways, you're actually solving this problem 3 different ways. Okay, in the table, I'm going to do hours as x, and I'm going to do earnings as y. All right, 1 hour is going to be $8.50. And I switch that. So we need 1 hour is $8.50. I need to get up to $127.50. So if I do 10 hours, then I'm multiplying by 10. So I would get $85. So I just did times 10 times 10. Okay, if I double it again to get to 20, that's going to be a little bit too high. So I could do 15 and test that one. Okay, so now I'm going to multiply times 15 and times 15 again. And $8.50 multiplied by 15 is going to give me $127.50. So that actually just happened to work out. I do want to fill in the entire table, so let's go ahead and include 20. If I include 20, that should give me a total of $170. So based only on the table, this value right here tells me that for 15 hours, you'll make $127.50. We get 15. All right, looking at the equation, we have a unit rate of 850 per hour. So that automatically means my equation is y equals 850x. Okay, we want to know for $127.50 how long we have to work. So that means that y, in place of y, I'm going to put $127.50. Okay, all I did was substitute my y value. And then I'm going to bring everything else down. And now I need to solve this equation. Yes, you do need to show these steps. So we're going to divide by $8.50 on each side. And now we've shown that it will take 15 hours to earn that amount. So we get 15. All right, next for the graph, we need to put hours on the x-axis. We'll label hours. And then we need earnings on the y-axis. Okay, we also need a title, so we can say something like amount of time to earn money. We could do an hourly wage. So we can just set money per hour as an example. All right, now we need some scales. So we know we're going to start at the origin with 0 on both axes. Hours, we want to get up to 20. So if we count by twos, okay, and then along the y-axis, we need to get up to at least 170. So let's count by $20 for each line. And if you counted by something else, that's perfectly fine. You don't need to change it. All right, now we're going to start plotting our points. So this is a proportional relationship, so 0, 0 needs to be one of our points. Okay, we're going to go over 1 up to 850, which will be about there. 10 is going to be 85, so that would be about there. And 20 will be 170. So that's going to be right about there. It is very important that you plot all of the points in your table. If you only plot 2 of them and you made a mistake on one of them, your whole line's going to be off. So always plot all the points in your table. Okay, and then if you did it correctly, they should form a straight line that passes back through 0, 0. Okay, now we need to know $127.50. We are going to need to estimate just a little bit. So that's going to be about right here in between 120 and 140. We're going to follow this all the way until we get to that line on the graph. And then we're going to go straight down. And we're right between 14 and 16. So that's going to be 15 hours. Okay, again, you need to solve it the whole way through, not just write what the equation is or not just draw the graph, but actually solve it to get your answer. All right, number 5, complete the table for the proportional relationship, and then we need to answer the questions. Right now I have a rate. This one tells me that it costs $1.35 for 3 cookies. It's always a good idea to find your unit rate, so I'm going to find out how much it is for 1 cookie. So in order to do that, I need to divide by 3 in the numerator and the denominator. So we're going to do $1.35 divided by 3. Okay, decimal's going to stay in the same spot. 3 goes into 13 4 times, and 3 goes into 15 5 times with no remainder. So that tells me that for 1 cookie, it will cost 45 cents. Okay, so 45 hundredths of a dollar. All right, now I'm going to work my way back up to the bigger numbers. So to get from 1 to 5, I need to multiply by 5. So I'm going to do the same thing right here. So 45 cents multiplied by 5. So we're going to get $2.25. Okay. From there, I can easily get up to 10 because 5 times 2 is 10. So I'm going to do $2.25 times 2. That's going to give me $5. Okay, and then my missing one, I need to figure out how many times 45 cents goes into $8.10. So if we divide that, $8.10 divided by 45 cents, we always want to divide by a whole number, so we're going to move this over 2 places. So 810 divided by 45. Okay, 45 goes into 800 or 81 one time. And then we're going to subtract So we get 6, 3, and then we're going to bring down the 0. 45 goes into 368 times. So 8 times 5 is 40. 8 times 4 is 32, plus 4, we get exactly 360. So that's going to be 18 times. So yes, it is out of order from what you would expect, but it should be 18, and that's okay if they're out of order. All right, part A, what is the constant of proportionality / unit rate? Unit rates must have a denominator of 1. So in this case, we're going to have to flip it. So this is 45 cents. We're going to write this as $0.45 is the cost for one cookie. Okay, can't stress enough, you have to have your units to get the point for a problem like that. All right, the constant of proportionality will be represented in the graph with the slope. So the graph will have a slope of 45 hundredths. Okay, write an equation. So we already know the slope, we already know the constant of proportionality, so we're doing y equals something times x, and in this case k is 45 hundredths. So y equals 45 hundredths times x. Okay, remember when there's a number in front of your x, that's a coefficient and it means multiply. Okay, use the equation to calculate the cost of 150 cookies. So we can see cookies is x. So I'm going to start with my equation. And in place of x, I'm going to put 150. So I'm going to do 0.45 times 150. Okay, we'll work that out. 150, 45 hundredths. Add them up. And then we're going to move our decimal point over 2 places to get $67.50. We have a word problem, so we're going to make sure that we have units with that. All right, number 6, looking at the graph, you can see how much money you and a friend are each saving for a camping trip. I know that your color did not go through, so just know the top line is your friend and the bottom line represents you. Okay, part A, compare the steepness of the lines. What does this mean in context of the problem? So when you're looking at that, if you look at the labels, and see what that means in context of the problem, that'll help you answer that. So we know that this is a problem about camping, and we're graphing our savings over a certain number of weeks. All right, so the blue line, your friend's line, is steeper. So because we're talking about how much you save per week, that means that your friend will save more money per week than the amount that you will save. So we can write, since the slope for your friend is steeper, your friend saves more money each week. All right, the slope of each line, I'll color code it the same way that they did. So in blue, the slope, I'm going to look at my rise and my run. Now, please don't say that this is 2 over 2 or 1. If you said that, that means that you didn't pay attention to the scale. This vertical distance went from 0 to 40, so that's a rise of 40. And then the horizontal distance went from 0 to 2, so that's 2. So we're going to write 40 over 2, which will simplify down to 20. That represents your friend. Okay, in green, we'll use the origin going up and over. So this had a vertical distance of 60, and a horizontal distance of 4. So 60/4. And then when we divide 60 by 4, we get a slope of 15. Okay, so that means that your friend will make $20 a week or save $20 a week. You only save $15 a week. So your friend saves $5 more than you each week. Okay, part D, the camping trip will cost you $165. How long will it take to save enough money? So we can use your information, which was $15 a week, and we're going to do y equals $15 a week times the number of weeks. The 165 is the number of weeks, and so we're going to divide that by 15. Okay, so 165 divided by 15, that goes in one time, and then that goes in one time again with no remainder. Okay, so that means that x equals 11, and it says how long will it take? So we will say 11 weeks. All right, number 7, a ferry boat travels 3 miles in 60 minutes. Model this relationship using a table equation and graph. All right, so we're going to look at if it can go 3 miles in 60 minutes. We want to find out how many miles or how many minutes it would take to go 1 mile. So let's set this up, miles and minutes. I'm setting it up this way because I know that my unit rate, I want to know 1 mile. So I can do 1, 3, and then whatever else I want to do later, maybe those numbers because they'll be easy to figure out. Okay, so 3 miles will take 60 minutes. So that means 1 mile will take 20 minutes. And I got that just by dividing by 3. And then 60 divided by 3 to get 20. Okay, now I'm going to work my way back up. 3 times 2 is 6. So 60 times 2, it would take 120 minutes to go 6 miles. And then if I do 3 times 3, then I can do 60 times 3 to get 180 minutes. And it's okay if you use different values. If you did 1, 2, 3, 4, that works. It just needs to be proportional. Okay, it says, how is the constant of proportionality represented in the table? We're going to say unit rate, and then we're going to list what it is. The unit rate of 20 minutes to go 1 mile. Okay, that's going to give us an equation of y equals 20x. This is x, this is y. We're taking all of our x values and multiplying them by 20. Okay, the constant of proportionality is represented, the value of k is 20. All right, now we're ready for the graph. So we're going to put, in this instance, we're going to put miles on the x-axis, and we're going to put minutes on the y. Now I know that's a little bit different than some of the others. We have talked a lot about time being on the x-axis. However, our unit rate, whatever the 1 is, that's going to be our x-axis. So that's why I'm graphing it this way. Otherwise, our slope will be flipped, our equation will be flipped, and it won't quite work out. Okay, so miles, let's just count. So here's 0. 1, 2, 3, 4. And then minutes. Let's count by 20s. Okay, title for the graph. Minutes per mile. And we're going to plot our points. So we're going to go over 1 up to 20, over 3 up to 60, right 6 up 180, one's going to go off a little bit, but it'll be about there. And then 0, 0 is also a point. So we can draw on the line. And actually, now that I draw my line, I see that I did make a mistake. So let's try that one more time. So I have over 1, up 20, over 3, up 60, over 6, up 120. I misread my table. So that's where drawing in that straight line can kind of prove that your points are plotted correctly. If you have a mistake like I did, you know to go back and fix it. All right, and then we're going to extend that line with an arrow on the end. Okay, and then the constant of proportionality is represented in the graph with the slope. So let's test it. We can draw in our slope triangle. We went up 20 over 1. So that is a slope of 20 over 1, which is just 20. So we would answer that by saying it's represented with a slope of 20. Okay, number 8, the graph shows the cost of buying tickets to a concert. Part A, interpret, keyword we keep seeing. Interpret the point 4, 122. Interpret means tell me what it means. So what does the point 4, 122 mean? If I look at my graph, the 4 represents the number of tickets. So 4 tickets. And the 122 represents the cost. So 4 tickets cost $122. So if you just look at the units or your labels on your graph, you can easily interpret that point. Okay, the unit rate, I want to know what this point is right here. Now it looks like it's 30, but if we do the math, it's going to be slightly off. I'm going to use this point. If 2 tickets cost $61, we can set up a proportion to find out the cost for 1 ticket. So to do that, we're just going to divide by 2 and divide by 2. So 61 divided by 2 is $30.50. Okay, so the unit rate, $30.50 per 1 ticket. Again, I have units to show that it's a rate. All right, part C, does the graph show a proportional relationship? How can you tell? So remember the things we're looking for. Does it pass through the origin? Yes. Does it form a straight line? Yes. So from the graph, those are the 2 key criteria. This would also give us the equation y equals 30.5x, which is in the form that we need it to be in, y equals kx. So we can say, yes, the graph shows a proportional relationship because it forms a straight line and passes through the origin. And that's our point 0, 0. All right, part D. We can use the equation. We can also estimate off of our graph. So the graph, it goes off, but it's going to be somewhere up off the screen over here. So we know at least more than about $200 as a rough estimate. Okay, so we're starting with our equation. Y equals 30.5x because it's $30.50 per ticket. You could also set up a proportion if it's $30.50 for 1 ticket. What would be the cost for 10 tickets? Okay, in our equation, we would substitute x with 10. Okay, both ways that we solve this, we're going to be multiplying $30.50 times 10. Okay, so the first way we get y equals $305. The second way y equals $305. So just make sure you have your dollar sign on there and show what you did to get your answer. It doesn't specify that it has to be the equation, so a proportion would be fine. All right, number 9, I think your sheet says number 10, but this is actually number 9. Your earnings are represented by the equation y equals 8x. So you make $8 per hour. Your friend is represented by the table. So if you can earn $36 in 4 hours, you need to figure out how much you could earn in 1 hour. You could also, I suppose we could also set up, let's do this both ways. So if I divide by 2, I can get the cost of 2. 36 divided by 2 is 18, and then I can divide by 2 again. So if you don't want to divide by 4, you can do that to get your answer. So 1 hour would give you $9. Okay, now we can work our way back up. I can multiply 1 by 6, and so 9 times 6 is 54. Okay, I can look and see 36 goes into 72 twice. So I can multiply 4 by 2 to get 8. And then if I use my unit rate and do 1 times 10, then I can do 9 times 10 to get 90. Okay, write an equation that represents your friend's earnings. So the unit rate was $9 per hour. So that would be y equals 9x. Okay, part B, we're going to graph both of these in the same coordinate grid. So let's say lawn mowing earnings. Okay, let's do x-axis is hours, y-axis is earnings, and we want to count up to 10 on the x-axis. And I didn't go quite high enough. Let's try that again. Okay, and then I want to count up to about 100. So let's just count by $10 each time. So 10, 20. Okay, so a little bit shorter than the full grid, but that's okay. Now we need to plot our points. So let's do this one, we'll do with green. So we have 1, 9, 2, 18, 4, 36. Have to estimate just a little bit. 6 is 54. 8 is 72. And 10 is $90. Proportional relationship, so it's a straight line through the point 0, 0. Okay, and then let's do red to represent y equals 8x. Okay, you make $8 an hour, so that means if you work 0 hours, you get $0. 1 hour, you get $8. 2 hours, you get 16. We could jump and do 5 hours would be $40. And 10 hours would be 80. So straight line through the origin, and we get a second line. Let's also label these. So this is you, and in green, your friend. Okay, or a key would also work. Okay, so part B we did on the graph. Okay, and then finally compare the steepness of the graphs. What does this mean? So we can see that your friend has a steeper line, and we just need to explain what that means. A steeper line means that you are making more per hour. So we would say your friend has a steeper slope which means Your friend earns more per hour. Okay, and then we can confirm that because your friend earned $9 an hour and you only earned $8. So $9 per hour versus your rate of $8 per hour. So maybe you need to get some tips from your friend on how to get a little bit more each hour. All right, that concludes the review sheet. Again, I hope you filled in anything that you missed or fixed or changed what you needed to. Use this to study, and good luck on the test.